Nano fam, finally we're back. Finally we're back with new development streams. Hello everyone. Hey, end of null. It's been a while. Just write something in chat so that I can put you on the spinner wheel and that you can win one nano every 10 minutes. So it's been a long time. I took some time off during Christmas. And then I was so busy with merging the upstream commits and with working for a client of mine that I didn't stream because all of the merge work is so boring. I didn't want to bore you with that, guys. Hey, you boo or Ju boo. Yeah, so I got your nano address. Let me just put that on the spinner wheel. And adding you to the address book. So how are you? So added. Okay. So a new year, and let's hope that this year we make it to a full Rust node. And with full Rust node, I don't mean like 100% is Rust, but that the node class and its dependencies are Rust. So that's my goal for this year, and let's see how that one goes. So yeah, so I was busy with merging the upstream commits, and that is done. So we are on par again with the C++ node. Hey Pies, welcome back again. Is this a new nano address? No, it's the same, so I can just put you on the spinner wheel. All right. So yeah, I just made a list of things I wanted to say. I start with the thing that I always say, like, if you don't have a Wirex card already, get a Wirex card. I'm not sponsored or anything. This is just so that Nano has more, how to say, there's more money in the Nano markets, and to just show support for the Nano currency and to actually buy stuff with Nano. Not directly, but indirectly, but that's better than not buying stuff with Nano. The second thing is I read a book over Christmas, and I can only recommend it. It's from Kent Beck, Tidy First. Do you know Kent Beck? I'm a big fan of his work, and it's a very, very thin book and a quick read, and it's about tidying your code, how to tidy your code and when to tidy your code, and I liked it a lot. So if you're looking for something to read, and you're interested in software design and programming, I can recommend that one. So for today's stream, as you've seen already in the title, I want to focus on the logging framework. Piotr did a lot of work on this on the C++ node, and I merged his work. Now logging. Let's switch to the screen. Now logging in Nano looks much better, and also the code is a lot simpler. So let's just start a node to show you Nano. Oh, I'm wrong folder. So Nano node. Let's run a beta node. Here, do you see that now? Now we have colors, we have log levels, info debug, warning, and it just looks a lot nicer. And it can also log to JSON format so that we can write scripts. Hey, Johnny Alstrom, welcome back. So I'm also going to put you on the wheel. So Johnny, just say Johnny. And yeah, so this is the result of all of the work Piotr did, and he migrated all of the logging code from a boost logger to this library called speedlog. And let's just have a quick look at the old logger, then the new logger, and then what we're gonna do in today for the Rust port. So the old logger was pretty basic. So let's just go back a couple of commits where I hadn't merged it. So a couple of commits back. Maybe this one. And let's browse the files and let's go to logger mt.hpp. So this file does not exist anymore. This is the old logger implementation. And the old logger was very simple. It just had the function always log, which would take would take the log items and the try log, and the try log would try to log it, and if there are too many log messages, it would just discard the log messages. So this is the old implementation which used the boost logging implementation, and now Piotr rewrote all of the logging code so that it uses the speedlog library, and that we can see here in the new logger class, and it has these debug info, warn, error, and critical. And what the cool thing is with this new library is that it supports structured logging. So that means we cannot just write string messages when we log, but we can attach arbitrary data. And this arbitrary data can be formatted as JSON. And so that makes our log files parsable with JSON parsers. And we can then further analyze the log files with scripts we write. And that is super, super cool. A lot better than just text files. So that's the current state of the C++ node. And that is also the current state of the Rust port. So we use the C++ logging stuff in Rust. So let's just sketch that in gschauwecker. Let's create a new one. Oh, this is the wrong gschauwecker? Yeah, this was the wrong gschauwecker. So I want to make a new one. And yeah, so logging. So we have the logger class, which uses speedlog. So the logger uses speedlog, and so this is the C++ side here, and here we have the Rust side. And on the Rust, we also have a logger struct, FFI logger, I called it, I think. And this just does callbacks into the C++ side. So whenever a class, let's just create something here, let's call it my component, wants to log my Rust component, oh, there's an N missing, component. So whenever my Rust component wants to log something, it calls the FFI logger, not directly, it is hidden behind a trait logger, and like that. So whenever my component wants to log something, that log call goes over to the C++ side, and the C++ logger then calls the speedlog library. And I don't want to leave it like that. Of course, we want to have a Rust node, and that means we want to have real Rust logging. And that's what we are going to start today. Already the first giveaway. Let me just quickly check the names. Do we have all of you on the spinner wheel? If you are not on the spinner wheel yet, quickly let me know. So Underfnall, Chu, Boo, Pice, Johnny A, and I think that's all. So if you want to take part, quickly post your name. And if you have never posted your nano address before, post your name and your nano address. Just giving you a couple of more seconds here. And Edie Bob is here. Anyone else? Okay, then let's start. Let's go. So the first nano goes to Hey, Jubu. Congratulations. So 1 nano for you. 1 nano for you. And sent. Oh, from account does not have enough. What? Oh, I haven't received the nanos yet. Yeah, now I do. Let's try again. Generating proof of work. Ah, okay. Sent. Oh, that was a bit unsmooth. Okay, so congratulations, and let's restart the timer. 10 minutes for 1 Bitcoin block. And then we instantly send out nanos. All right. So in Rust, there is 2 very popular libraries for logging, and one is the log crate, and the other one is the tracing crate. And I want to bring the logging to the tracing crate because let's add that here, tracing, because Piotr also worked on adding tracing information so that we can debug the node and just gain a very deep insight of what's happening in the node. And this really cool Rust library tracing, it supports like normal logging and structured logging, and it supports tracing. So that's why I want to move to this crate, and that will help us also making our Rust code more Rust idiomatic and faster. Because how it works right now is really, really bad. Let me show you if I can. Let me see if I can find a usage. Where could I? Let's go to logging RS. Logging RS. So this is the FFI logger. And and this implements the logger trait. So now let's just search for usages of info maybe. Or debug. Oh no, there's no usage. Maybe debug. Yeah, here we have a usage. So have a look at this code here. So this creates a debug log message. And so the quiz is, do you spot what is a problem here? Do you spot what I really don't like about the way that logging is currently done in the Rust node? Any idea? So it calls here self.logger.debug. It gives the target and a message. Any ideas what's the problem here, chat? No? Okay, then let me tell you. So the problem is that we heap allocate the message here with the format, and we do this even if the debug logging is disabled, and that is bad. So that means whenever currently there's a debug log message and we turn off the debug log level, it still creates the log strings and then it just frees them again. And that's just wasteful. So that is not a good way to log. Hey, Wenderson, when Nano is the light. Yeah, let's add you too to the spinner wheel. Nano is the light. Wenderson. And yeah, so this just creates a lot of unnecessary heap allocations. And it also takes up processing time with creating these strings. And with the tracing crate, logging would look very different. So this is the documentation for the tracing crate. And here we can log with macros. So we could log like this with the event macro. And they even have short forms for info and warn. So is there an example maybe? No. No. Oh, here. Yeah, so here we can, this is how we can log with the tracing crate. The debug macro, and we can give a message, and here we can give arbitrary data. So this is the structured logging, the same as the C++ logging implementation can do right now. And because this is a macro, it makes sure that nothing here gets formatted and heap allocated unless the debug level is active. And maybe, I'm not sure how it works under the hood, and maybe there is not even a heap allocation involved. I don't know. But if you are interested in this, Fiona, he just posted the link to the stream. Oh, I forgot to copy the link. So on YouTube, there will be a live stream from John, what's his name? Jingset. So it's this famous Rust streamer. He will have a look at the internals of the tracing crate, and I'm going to watch that. And if you're interested in this, yeah, just search him up, look him up on YouTube, and he is going to stream, I don't know, 2 days or 3 days about the internals of this crate here. So that is the plan. I want to go to using these macros and to not use a debug struct or a debug trait. So those will be deleted. And yeah, so that's the plan. So the Rust, the FFI logger, let's make that one red. We want to delete this. We want to have, we want to use the tracing crate. And that means we have to, yeah, let me also make that red because this will be deleted. So we have to change that so that the C++ logger does not go to speed log anymore, but it should go to the tracing crate like that. So let's make that green because this is new. And my component, so red, we're going to delete all of that. So my component should use the tracing crate, the tracing macros. So that is the plan. Makes sense? And let's start. Let's start with this. Oh no, let's just, I forgot to show you Piotr's tracing PR. I wanted to have a quick look at the tracing PR because this is not merged yet in the C++ node, but I think it will be merged very soon. Here, tracing. So what Piotr did here is he added the ability to create trace messages with this structured logging framework. And can we just open an example here? Maybe channel. Yeah, so here, this helps with debugging. So we can just add very detailed trace messages here, and we can attach like the message, the channel, and all of this additional data. And that helps us when we want to investigate a bug or performance issue or whatever, really. We can get a very detailed log of what happened in the node. And we can even write scripts that analyze the log messages. And this will be merged very soon. And we can do the same thing with the Rust tracing crate. This would be the trace macro, and we can just give a message, and we also can give arbitrary data here. And that arbitrary data will be formatted as JSON. Or not. So we can even configure how it is formatted. I think there's an example here of the different output formats that are supported out of the box. How was it called? FMT, the FMT subscriber. I've never used the tracing crate, by the way, so this will be my first time too. So where is... Oh, 10 minutes passed again. I have to speed up. Yeah. So 1 nano 4. One nano 4 pies, is it you? Yeah, it's you. 1 nano for you. There you go. Congratulations. Okay. Where is... Oh, I should have created bookmarks here. Like... Yeah, it doesn't matter. I won't... or am I finding it? Tracing subscriber. Yeah, this is the correct crate. Documentation. Layers, filters. FMT. Yeah, so this is an example and sample output here. So this will be the human readable form of the output. Looks a bit different, but it has the same things like the log levels and the arbitrary data. And this can also log spans, and spans are something with a start and a stop, like a function call start and a... Oh, no, timer. Thanks. Thanks, Johnny. Restarting. So this is the human readable form, and you can also generate JSON. And this is the JSON form. And as you can see, this is one line, a JSON object per line. And with this, yeah, we can create very powerful scripts and tools for analyzing our nodes. Yeah. Okay. And we can even load this into graphical profilers. So that is a cool thing. So there's the tracing Chrome crate, for example, which creates Chrome compatible outputs. And then you can create these graphs here where you can visually see the trace. Hey, 1401. Damn, I'm late for the RsNano stream. No, you're not too late. We're just still talking about what we are going to do. So let me add you to the spinner wheel. 1401. And so this is the plan. And let's do this in small self-contained steps so that we don't risk in anything. Let's keep everything releasable at all times. So the first step is that we go to the logging HPP file. Oh, oh, Vim was already running. Okay, so let's go to the logging HPP file. This is the Rust, the C++ logger interface, and what we want to do is we want to replace all of these calls, these speed log calls, and we want to route them to our Rust code. And yeah, how can we do that? So let's maybe, as a first step, create an FFI function. Let's create an FFI function on the Rust side. So right is Rust and left is C++. And this will be used for creating a log entry. So let's call this RSN log. And this should take the log level. The log level is, let's say, it is a U8 byte. And it has to take the message. And message, like that. So just a char pointer, a const char pointer. And we don't worry about the structured data for now, because obviously the C++ parts that use the logger, they don't log just messages, they can log additional data. But I want to keep this simple, and I don't want to worry about that right now. So what I want to do is very simple. First thing is I want to pass a log level and a message to the Rust side, and the Rust side should log that. And I want to make it even more simple. I don't want to use the tracing crate immediately. What I want to do here is I just want to print it to the std out. So let's do that. I just want to do a print line of the log level and just the message. But I have to convert the message to a string, to a str. How can we do that? Oh, how can we do that? I haven't done that in a while. Isn't there a C-str? C-str? How can I create a C-str from a pointer? As pointer to string is empty. Chat, help me out. Do you know how I can do that? As pointer to string. Is there a way to create a C-str from a pointer? Okay, let's Google that. Return C-str use to create a pointer to member using C-str. C-string, C-str. From pointer. There's a from pointer. I didn't see a from pointer here. Oh, there it is. Okay, that's easy. That was easy. From pointer. So here we have a C string, and then let's just convert that into a string. Let's unwrap that. And this is our message now. And then we just print the message. Okay, so this is the very first step. An FFI function that just prints raindrops. Hi, raindrops. Do you want to take part in the giveaway? Are you in the address book already? Let me just check. Address book. Is that alphabetically sorted? No, it isn't. Oh, you are. Okay, so let's add you to the wheel. Okay. 2 minutes 50 seconds, and then we give away the next nano. Yeah, so this function now, we want to call this function now from the C++ side. So we have to format the string first, because what we get here is the args and the format string, and this does some speedlog magic here to create the final string. And we want to do the same speedlog magic and end up with just one string that we can pass to the Rust side. So we want to say, okay, how does this work? The speedlog level. Okay, so this one is just a string already. So here we can just say, here we can just directly call our new function. So we can say RsNlog. And what was the name? Yeah, just RsNlog. And we have to cast the level into an U8. What is level, by the way? Okay, here it is. Trace, debug, info, warn, error, critical, off. Okay. So we just have to cast that into a byte. And then we just have to pass the message as a pointer. So message cster. Okay, so there is an error here. What is the error? No member RsNlog. Okay, why is that? Is there no log? RsNlog function? Let's trigger a build. Let's trigger a build. Yeah, now this is the bad part, because now it has to recompile the whole node, because this logging HPP file is included everywhere. So now we have to wait probably a long time. Okay, but I think there is no real problem here. Maybe it's just a missing include. Is that the... Yeah, the include is missing. We don't have the RsNano HPP included. Okay, that makes sense. Okay, let's give away one nano. Oh, raindrops, it's looking good for you. Yeah, it's you. Congratulations. Raindrops. 1 nano. There you go. Congratulations. Okay. Timer running again. Okay. Yeah, so I have to include rsnano.hpp, but I don't want to include rsnano.hpp here because this header file is included everywhere. So let's move that to the CPP part. Let's move it here. So this is the CPP file. Nano logger log. Redefinition, yeah, so here we have to delete the implementation. And now the error. Error is gone. Okay. So that was easy. That was the first. So let me, oh no, it's not compiling. So let's go to the second one. The second one is trickier. The second one gets the message template here, and then the arguments here, and then it somehow formats this into a string. Can I move this to can I move this to the CPP part as well? I don't think, is that possible with C++? Because it uses template arguments? Is that possible, chat? I'm not a C++ expert. Let's try. But maybe it doesn't work. Nano logger. Log. Redefinition of log. So can we just comment this out? Does this cause? Yeah, no. This works. Okay, how is this possible that this works? I would have guessed that this doesn't work. Okay. Okay. I'm not complaining. Yeah, so here here we have to format the message. And let's just go into the speed log implementation. And let's see how that is done there. So this is the speed log source code. So it calls to string view of the FMT. So let's do that. And then what does it do next? Oh, sorry, that was the wrong place. I wanted to go to the log implementation again. It creates a memory buffer. And it calls some format function. Let's copy that. Oh. Wrong file. Let's copy that and let's put it here. So details, so speed log, I guess. And this memory buff T. Where does that come from? Format. FMT. Okay. So FMT. Memory buff T. No type. Memory buff T. Namespace FMT. Did you mean? Okay, speed log. FMT. No type name in namespace. Oh, you can't see. Oh, I can't see it because of the overlay. Sorry, chat. Yeah, I have to remove the winter overlay again. I had no time to do this. No type named memory buff T namespace 70. You mean? Why does the error message still say that it is? Oh, did you simply mean FMT fix available? What? No member in... Okay. Like that? Did you mean SPD log mem... Oh! Sorry, chat. Yeah, this works. And then we format the args and the result is in this buffer. And... buffer has, what does it have? Data and size Data and size. Oh, it's not null terminated then, isn't it? So then let's change our FFI function that it takes the length. Because I think this is not null terminated. Or is it? Is this null terminated or not, chat? What do you think? I think it's not null terminated. Okay. I'm going to just pass the length. So let's say our RsNlog function does not just take the pointer, but it also takes a length. From pointer, is there from pointer with a len? No, there isn't. Then let's create a slice maybe. And let's create a slice with message in len. And then can we create a C string? No, we can't. A C string is always null terminated. But we can maybe just directly create a string slice. UTF-8. Oh, chat, I'm not so sure if this works. We will see. Oh, we have to unwrap. What's wrong here? It takes a U8 slice. And what is data? Oh, it's okay. C char U8. Okay. Let's try. Okay, so now we pass a pointer and a length. So let's get back to the C++ part. And then we have to change. Yeah, we have to change this place here. We have to give the length. And C string is a const char pointers, but it has to be a... Oh, how can we fix that? C string. C string. Data? What is data? Const char pointer. What is the difference between data and C string? This returns char pointer. Char pointer, and buff. What is buff here? Buff data is also char pointer. So maybe let's make it take a char pointer, because that is just more convenient here, because otherwise we have to cast this into byte pointers and yeah, let's keep this char pointer here, and then we okay, does this work already? No. What is data? Data is now I8, but it has to be U8. Chat, what do you think? What would be the best solution here? Okay, let's give away the nano first, and then we find. I think we will find a solution. No habla Rust, says Underfnall. Wenderson, Elibob. Elibob. Congratulations. Almost, says Wenderson. Yeah, it was so close. It was so close. So the simplest thing here would be if it was actually just a C string, a null terminated C string. But I'm not so sure how this FMT appender and V format work. What does it do? Output iterated appends to buffer. It is used to reduce simple size. So I think this is not null terminated here. Croptor is here. Hey, welcome back. Croptor. Yeah, so let's chat. What can we do now? What can we do now? Maybe we do a mem transmute. So let's transmute it from a C chart to it. Oh, there's a colon missing. Unsafe stuff. So we just reinterpret this as a byte pointer, and then we create the message, and then we print it like that. I think we can go on like that. Okay, let's go back to the C++. And yeah, and oh, by the way, chat. So today we are preparing everything so that we can log from Rust with the tracing library. But then we have to find all the places in the Rust code that still use the old logger, and we have to convert that to tracing. And if you ever wanted to help with the Rust Nano node and you just didn't know where to start, then this is the perfect first thing that you can do to contribute, because there's not much that you can do wrong here, and it has to be done. And so if you like to help, then just watch until the end of the stream when we have this new logger running, and then you could help me and just find all of the places in the Rust code that still use the old logger and convert that into the new tracing loggers. Okay, so data C string. Okay, so here we have, no, wait a second, FMT. Do I have to convert this to a string view? What does vformat to take? Basic string view. Okay, so I think that's it now. So we have our buffer. Cropter says, can't you just click Ctrl+F, then write the old logger thing and then replace all automatically? Not Not sure. Not so sure because maybe. I'm not so sure. Would be because these old loggers they are multi-line things, and yeah, so maybe with a regular expression and yeah, I don't know. Maybe you can help me out with this. Okay, so we have the buffer, and the buffer has the data. So can we say we buff.data, and the size of the message is buff. Is that size? Like that. Okay, I think this is the first walking skeleton here, and I want to compile and see if this works or if this crashes. So just to recap what we do here, is we create the final message string, and then we pass that message string and the log level to Rust, and Rust, on the Rust part, where is the Rust part? Here. On the Rust part, we just convert those pointers back into a string, and then we just write it out on to the console. And let's see if this works. And before I compile everything, maybe I can also quickly convert the other log instances, log functions. Can I? Oh, sorry, wrong file. I was just confused. I wanted to go here. This is the logging HPP file. So maybe can I just redirect here? Let's comment this out. Can I just redirect you to the log function with the level nano log level bug and FMT and args? Does that work? Expression contains unexpanded parameter pack args. Oh, I can't pass the args like that. Okay. Yeah, then, because I'm not even sure if this is being used. Yeah, it's not being used really. Not a lot. Okay, so then before I compile, I just have to to bring all of them, to make all of them call the Rust code. So let's copy that, the debug. And this is a nano logger debug. And I'm just copy pasting everything right now. I don't worry about the duplication. So this is nano log, because I can fix this duplication later. So this is debug. No. Not type level. So this is the debug call info. Let's also copy that over to the CPP file. And the logger info. And copying the code here. Oh, yeah, the overlays. Blocking your view chat, sorry. Crapto says, I'm no programmer, I just to that with Word when I figure out I wrote a word wrong every time. Yeah, maybe it is possible to convert that automatically, but my guess is that it's quicker to just do it manually. info. So that is info, yeah. So info as is the log level info. And here we have another info. And that is nano logger info. And this does not do any formatting, so we can just, like we did up here, we can just say tag. Oh, I'm missing this argument, yeah. Okay, it doesn't matter. It doesn't matter. We are just trying to get this to work somehow. So analog level info. So I'm just duplicating a lot of code here, and duplicating code is bad, but it is temporary. We are not. So that's enough here. So we have all the info calls and the log and the debug calls, and this is enough to see if this actually works. And to see if this actually works, I want to change the log message so that it contains from Rust. So if we see from Rust, we know that it worked. Yeah, let's compile. Let's compile. And let's give away 1 nano while it compiles. One nano for 1401. Congratulations. Okay. Yeah, compiling. Raindrops when V26. I don't know, it could happen anytime, any day now. So it is really well tested already. And there's no rush. There's no rush to bring it out. But I think it will come out very soon. 41 thanks straight to the Nano GPT. Yeah, Nano GPT could help here. Hey Johnny Alstrom, Nano is the light, just it? What? Yeah. Compiling. Nano fan, what do you think? Will this work? Or will it crash? Will this work or will this crash? Oh, by the way, I started. Windows says, I think it will work. 1401 says, I will work 100%. Oh, you guys are sure. Very confident. It would be cool if we could place nano bets in chat. I bet 1 nano, it crashes. Yeah, so 75% still compiling. Yeah, while this compiles, I started a beta bootstrap with the Rust node today, and it doesn't go as fast as I thought it should. So how many? It has 32 million blocks cemented right now, and cementation rate really went down, and so there must be some issue that I have to find. So if we go back last 12 hours, Even more. 24. Yeah, so here I deleted the ledger. And then I started a new bootstrap. And it went really fast in the beginning. Here with 2000 blocks per second. And then it got very, very slow. And now it's just bootstrapping with... Now it's just bootstrapping with average 200 blocks per second. So there must be a bug in there somewhere. And I have to find that. Johnny says it will work. Raindrop says if it worked, it worked. And if it crashed, it worked. It is a progress, yeah. It is a progress. Oh, come on. These recompilations, they are so bad. And when we work with the logging HPP file, we have to recompile everything. Ah, what's that? Oh my god. A huge error message. What does... Have you ever seen an error message that long? What does it say? Yeah, okay. Ah, I knew it. I knew it. When I said I was surprised that this worked. We can't move functions with template parameters in from the HPP to the CPP file. Oh, that's horrible. Fortune01 says at least Twitch chat has an API, so making a simple chatbot is quite easy. So maybe the Twitch chat betting bot would be your next project after RsNano. Yeah. so that we can all place nano bets. Okay, so the problem here is that we can't move templated functions to the CPP file. So they have to be in here. Okay. Okay. So let's just move all of them back. Oh, that's bad. Oh, yeah. Let's move all of them back. Let's include RsNano HPP. And let's fix this later, because the reason why I didn't want to do this is because of it increases recompilations a lot, because now whenever we change the FFI functions, it means that we have to actually recompile everything. But this, I think I can fix it later. Yeah, let's fix it later. Let's just move all of that stuff back. Debug. And then we have info. And, oh no, info, and we have this one here as well, and then we just delete this C++ stuff here. Okay, and we should be fine. Let's recompile again, and now we have to wait again. Build. But let's not make all tests. Let's make a nano node. Sorry, chat. We have to wait again. So when is the next Nano giveaway? In 2 minutes. So let me just scroll through my list. So we have this. Yeah, I said everything I wanted to say already. But while this compiles, let me just have a look at the Rust code that we have to migrate from tracing, from the old logger to the tracing logger. So that is the starting point here is the logger.rs file, and this defines the logger trait, and if we just search for usages of the logger trait, then we find all of these usages here. And so what we have to do here to convert them to the Rust tracing logger is, yeah, we have to go through all of them. Let's just take this one, for example. And so this would be debug. So I'm not saving that. I'm just showing you what we have to do here. So this would be debug. And the log type, so this is not needed in Rust. So this is the target. This is used so that we can filter log messages, and filtering log messages can be done with just the module names in Rust. So this is not needed. And then we just have to copy that part here and place it in here. So this would be the new format, and this would be deleted then. Make sense? So let me undo all of that, and let's give away the 1 nano. Oh, is it Wenderson? Is it Nano is the light, Wenderson? Nano is the light. 1 nano for you, Wenderson. Send instantly. And with very low energy. Okay. So, oh, the compilation is done. Okay. So let's run the node. Oh, and that, oh, look at that. It worked. It worked. Chat, you were right. You were right. It worked. It worked. It worked. As you can see here, it says from Rust, from Rust, from Rust. The number after from Rust is the log level. I think 1 is info and 2 is debug, or the other way. No, 2 is info, 1 is debug. Yeah. It worked. So that was successful, a successful first step. So that means so this was my biggest worry. So everything from now on will be simpler. So yeah, so now that this works, we can make it good. So I copy pasted a lot of code here. And let's see if we can remove the duplication. And let's see if we can keep the RsNano include file out of here so that it does not recompile so much. Let's delete all the things. Yeah, and if not, let's delete all the things. Oh, yeah, the timer's running. Okay. Yeah, so let's just keep the string formatting in here, and then let's delegate to another function, and that other function will call into our RsNano, into our Rust. So yeah, let's do that. Let's create a function. Just a simple function, and that function will be called log with Rust. And it will take the log level and the tag and the message. And what will the message be? What will the message be? Const char pointer. And size. Like that. So let's implement that. Nano log with Rust. And this helper function will just call our Rust FFI function. Okay. It converts to the log level. It sends the message pointer and the size. And we also have to send the tag, but one step after the other. One step after the other. So first let's remove RsNano HPP again from our logger HPP. And now let's use our helper function everywhere. So log to Rust. Oh, no. Nano? Is it nano log to Rust? Oh, I have to declare it before I want to use it. So I have to declare it here. So again, log to Rust. It takes the level and it takes the buff.data and buff.size. Oh no, log with Rust. What's the name? Log with Rust. And still something missing. Oh, the tag is missing. Okay, the tag is missing. Okay, so let's copy this to here. And here the level is nano log level debug. And here the level is info. And same down here. The level is warned. And the level here is error. And the last one is critical. And now we just have these two last functions missing, who just take the message string. So here we say log with Rust. The level is info, the tag is the tag, and the data is message.cstring, and the length is message.length. Oh, same. The last one on the top needs the same fix. The level is... Oh, we have the level as an argument. Level tag. Okay, so now our logging HPP file does not include RsNano.hpp with all of the FFI functions. And we have just a single function here that calls into our Rust part. And the one thing that this function still doesn't do is it does not send the tag. And the tag is something that we can later use for filtering log messages. And I think we can just create a string out of a tag. Is that right? Can we create a string? ToString creates a string view. ToString. Okay, let's try that. So we can say tag string is ToString tag. No? Oh, it's the namespace was wrong. The namespace is nano log. Now we have a string view. What is a string view? What can it do? It has size, length, data. Size, length, data. So can we say tag? We have to pass the tag. Can we convert that into a C string? Tag string? I don't think we can. Data and length. Okay. We have data, we have length. So let's just pass that to the Rust. Oh, what happened? Oh, I lost track. Back to logging.cpp. Sorry for the confusing navigation here. I just pressed the wrong button. Yeah, so let's just pass the tag string data and the tag string length. To Rust. And that means on the Rust side, we have to add that here too. We have to say tag is a constant char pointer, and taglen is view size. And then we just have to do the very same thing here with that we did with the message. So we say tag is tag and taglen, and then we convert tag into a string, into a str. And let's just print it as well. Yeah. So let's run a build here. And let's give away the nano. Crofter says, what do you think about Monero being delisted from exchanges such as Binance? It makes me so sad. Like, I'm a strong proponent of privacy. And to delist a privacy coin, I think it's just wrong. And if now, congratulations. What do you think, NanoFam? I'm a fan of Monero, actually. So Andefnal, you won? Who won? Yeah, Andefnal. Where is Nolt? Yeah, it's just sad. I mean, obviously, like, Monero is a threat to certain very powerful players in the world. And yeah, but I think it will survive. I don't think Monero needs a centralized exchange to survive. Okay, so while this compiles, we can maybe just recap what we did and think about the next steps. So this is our Rust function here. It takes the tag, it takes the message, it takes the log level, and it just prints all of that to our terminal. And it shouldn't. It should use the tracing library for that. So let's do that. Let's do that. So let's add the tracing library. So I'm going to the Rust folder. Where is the logger? The logger is in Node? No. Which folder are we? So logging. I think I want to add it. Or do I have to add it to FFI? Yeah, let's add it to the FFI part, because this is the place where we are using it right now. So let's say cargo add tracing. So, okay, log, async, await, log always. What are these features? What is the log feature? What is the log feature? Are the features listed here? Somewhere here, feature flags. Feature flags, log, what is log? Are they described somewhere? Okay, so I don't know what it does. We will find out. Okay, so we added the log. The log dependency, the tracing dependency to our FFI crate. But I just want to, I don't want to have a hard-coded version here. I want to have the hard-coded version in the executable. So, okay, so I think we can use that now. I think we can just say event. And what was the syntax? What was the syntax? Where is the event? Span. Concepts. Here, level, info. Okay, so we have to convert. We have to convert the log level first. So that means we have to have the same enum as we have in C++. So that is this one. So we have the level. Let's call the CPP log level. And let's derive from primitive so that we can create this out of a byte. Kautschuk says, hey Gustav, einen schönen Abend. Yeah, nice, have a nice evening, you too. Cannot find derive macro from primitive in the scope. So let's import that. Okay, and what else? Yeah, so we have to convert the log level into log level from... Yeah, we have to convert this into the tracing. Where is it? Tracing level. Tracing level. So that we can convert the levels. Yeah, so we have to convert all of them. So trace is tracing tracing level trace. Why doesn't code completion work here? Why doesn't code completion work here, chat? Oh, the compilation finished. So a quick detour. I want to run it and see what happens. Oh, no, not building again. I want to run it. Oh. So it says from Rust. Yeah, it worked. So as you can see here, the node, can you see that? This is the tag. So here we have the tag node. Here we have the tag bootstrap, the tag all. This is the log level, and this is the message. That's great. Okay, so we have to convert the log levels into the tracing log levels. And what's wrong here? We have a couple of errors here. Num traits from primitive is imported here, but it is only a trait without a derive macro. Okay. Okay, so that means maybe there's something missing in the cargo toml. Maybe where's... Oh, there's no from primitive in here. Maybe that is the problem. Let's add it here. Let's just copy it from the node. No, wait a second. Where is from primitive? Is it in the node? Is it in core? From... Is it in core? Maybe it is in core. Oh, it's in num traits, num derive. So these are num traits and num derive. These are the imports I need. So let's check that again. So there is num traits, but there's no num derive. So I need this, I guess. And with that, it should be it should work, I hope. No. Cannot find derive macro from primitive in the scope. Howchick says, oh, I missed some messages here, huh? AAK, hello peeps, says AAK, are you in the address book? Are you in the address book? Yes, you are. So let's add you. And let's go. Kauchik asks, are you using NeoVim? Yes, I am. I am. I switched to NeoVim a couple of streams ago. Really happy with it. Bob, 1 nano for you. There you go. Instantly confirmed. So what's the problem here? Cannot find derived macro from primitive in the scope. What's wrong here? What's wrong here? What's wrong here? From primitive. So I have num traits, num derive. So what's missing? Do I have to import num derive? I think maybe like that. Maybe like that in here, maybe. Unresolved extern crate. What? I have num derive in my cargo toml. Here it is. Maybe it's a caching issue. Let's close NeoVim. Let's do a cargo check. Yeah, this doesn't have the error. It was a caching issue. It was a caching issue. Okay, so level no item named trace found for struct level in the current scope. So what's wrong here? So we have level, inner level. So tracing level. So what is wrong here? Let's check the documentation again. Level info, and level is tracing level info. Oh, it's all uppercase, all capital letters. So trace like that. Oh, okay. So that's it. So tracing level debug, and maybe we can let's just import level so that we don't have to write tracing all the time. So info is level info. Warn is level warn. Error is level error. Critical is level. Oh, we don't have critical, so we just keep it as error. And off, what is off? Is level. Yeah, off. What is off? Let's just keep debug. I don't think this is actually used. Okay, so now we can convert from the C++ log level to the tracing log level. So here we can now say let level is level from no, first we have to convert it to let CPP level is CPP log level from U8 is a from primitive from U8 log level. So now so first we convert it into the enum, the CPP log level enum, and then we convert that into the tracing log level. And then we can finally give it to our event macro. Oh yeah, and this can fail, so we have to unwrap it. Okay, so here we have the level. Let's check the documentation again. So we have the level, then we can pass a string. And I also want to pass the tag. And the tag, I think there is called target here. So how can we define the log target? Event. Target. Target. Okay, so we just say target. So level target. And target would be tag. Like that. And then the message. No? Oh, maybe the target comes first and then the level? Attempt to use a non-constant value and a constant, non-constant. Okay. What does target have to be? Oh, this must be constant. This must be constant. Oh, that's bad. Kautschuk asks, now if you turn logging off, it is logging everything, right? If I turn logging off? I'm not sure what you mean. Yeah, the nanomac filled with water, guys, with water. So the tag. Let's just keep the tag out of it for now. Let's just use the log level and the message. And I wanna, so let's add a to-do log tag as well. Attempt our level. Non-const. Why can't I do it like that? Level. What is level? Oops. What is level? It's a level. So why doesn't that work? Attempt? Or is this still... Is this a caching issue again? Let's run a cargo check. One more time. Non-constant value. Consider using let instead of static. Consider using let instead of static. Let call side. What does this mean? Expected identifier. What? Why doesn't this work? Why doesn't this work? NanoFam, I need your help. Macro rule. So we have a name. Target. Level. Expression. I'm a bit stuck. Right now. Oh, and I did not restart the Bitcoin timer. Huh. Kaochuk says, you mapped off to debug instead of error. Yeah, because I think that the lock level off means it should not be locked. Which is weird. It doesn't make sense really. Why is there code then? So I just mapped to debug. I don't think lock level off is in use. Underflow says he was talking about that original log off in the match. Oh, okay. So that, yeah. So that was on purpose. So the lock level off means it should not be locked, and yeah, I just put that into the lock level debug, or even trace. It doesn't matter. Let's say trace. I think lock level off is not being used, but I'm confused. Why can't I just put the level in here? Because I can say level debug. So this works. This works. But when I say level, it doesn't work. Chat. What's wrong here? How can I make this work? There must be a way to make the level non-constant. Kaochik says, wish I could help you, but I just started learning Rust. Oh, there's more about const level works. Const level? No, I don't think so. Let's read more about the event macro. Is there more examples? Maybe no. These are the only examples. With the level and up to 32 key value fields. Top level documentation. Yeah, so the target here. So this is the tag. I wanted to log this as the tag, but this also did not work with non-constants values. You know, guys, I'm stuck, so let's just pick an ugly solution. Because we have to get on here. We can't stay stuck forever here. So let's just pick a very ugly solution with a match statement. And let's just duplicate the code because I want to see if it works. And then I can work on making this work. can't match on level? Oh, it isn't an enum. What is inner level? Inner level is an enum. Why is level a struct with an inner level? That's really weird. Why did they make it like that? I was expecting level to be an enum, so that I could match over it. Derive, copy, clone, debug, partial, equal, hash. And if null says, we heard you like enums, so we put enums inside your enums. Okay, let's make it even worse. Let's just add a couple of if statements here. Nah, that's also bad. Because can we access? No, we can't. Level, what is it? Debug, trace. This should work. Yeah. So yeah, let's just add a couple of if statements here. And this, don't worry, NanoFam, it will not stay ugly like that. We just have to get it to work first, and then we make it nice. So let's just add a couple of if statements here, and then let's say event level trace message. Does this work? Okay, this works. Okay, so else if level level debug, then we say level debug, and I'm going to figure out a better solution after the stream. Else, let's just copy all of that a couple of times. Debug. What do we need? We have trace, debug, info, I think, warn, debug, info, warn. Coaching says, let's make this a problem for future Gustav. Yeah, that's a problem for future Gustav, not for me. Future Gustav will figure this out somehow. Warn. What did I miss? Error is still missing. So this looks really stupid, but it works. Okay, CPP level converted to. Okay, so this is the wrong naming convention. Okay. Oh, that didn't work. Okay. Okay, so that's it. That's it. NanoFam. I think the only thing missing now is we have to activate our tracing logger so that it actually writes the logs to the terminal. And let's do that in... Where can we do that? Maybe the callbacks, FFI. Functions. Where could we do that? Oops. Where can we add the code that activates our logger? Where is the place? Is there some init? Because this is the last... oh, that's not the file I wanted to open. Callbacks. It's nano callbacks, CPP. So maybe in here... So, is this the last nano? No, is there still 2 left? Really? Okay. Spin the wheel. Oh, Kautschuk. Are you on the wheel? No, you're not. Now you are. Start. We are so close. We are so close, and I'm going to finish this today. Even if the stream takes 10 minutes longer. Hey, God, I put you on the wheel and you win. Congratulations. Yeah. Are you? You are not in my address book, Kautschuk. No, I don't have your address. Just write your address in chat and you get the 1 nano. No, you're not in my address book. There's nano callback. So this is the callbacks file. Kautschuk says, sure, quick sec. Yeah. I'll wait. Maybe I'm... Yeah, let's introduce a new FFI function that initializes the logging system. So let's call this RSN log initialize or init. And we just call this here RSN log init. And this should initialize the logger. So, oh, Kautschuk sent his nano address. Address book. Save. Okay. There you go. RSN log init. Yeah, so here we have to initialize the logger. And how to do this. Fast tracing subscriber. How to do this. So we have to add the tracing subscriber crate. Let's do that first. And yeah, so we have that. And then what do we have to do then? Are there no examples of how to use that? No? FMT and STD only. So do we have this feature enabled? Yes, we do. Okay. So how to init? So just init? Okay. Let's just try the defaults. Let's just call this one. Okay. And that should be it. So now let's recompile everything and let's test it. So let's make nano node. Okay, it's compiling tracing and tracing subscriber. And this should be the last thing that makes our logger active. Yeah, a couple of warnings, but that's okay. Unused stuff. Yeah, so while this compiles, let's just quickly, one more time, talk about what we have to do to convert all of that now. So I think we still have to add the tracing. Yeah, the timer. I know the timer, but we just have one nano left. And I'm going to give away the last nano in a minute. So we don't need the timer anymore. So I just want to add the tracing dependencies to it. They are just currently in the FFI crate. So I want to add them to, where's tracing? So I want to add them to the node. And the ledger maybe? And the ledger. Yeah, no, just the node, because in the node we have to use that later. So yeah, so now we just have to find all usages of the file logging rs. Is it logging rs? Logger rs. Sorry guys, logger rs. And there's the trade logger, and we just have to find all usages of those functions here. Like let's search the debug one more time. For example, this one. And then we have to convert this into debug. And just this here. Like that. And this then has to go. And we have to do this everywhere. So if you want to help, please feel free to do that. Like to look for all the usages and to replace them with the tracing library calls. And then open a pull request, and I will merge it then. So that would be great. Or if you guys don't want to do it, I'm going to do it. But sometimes people ask what they could do, and this is a really good first task, I think. Yeah, so it's still building. So let's give away the last nano. Yeah, Johnny, congratulations. You won the last nano. So, okay, sent instantly. Congratulations, Johnny. Building is 98% done, so we should be able to run it in any minute now. 100%. Come on. 101%. Linking? You guys can't see that, can you? That stupid winter overlay is hiding it. Done. Okay, so let's run it and let's hope for the best. Who? No log. Oh, maybe because... Wait a second. Config file. So it's not writing anything. So maybe... But it's also not crashing. So maybe our... maybe this tracing subscriber fmt init is not enough. Enables you to filter events at runtime using environment variables? Or do we have to set environment variables? Do we have to say rust log debug? Let's try that. Do we have to say rust log? Is this rust log debug? Oh, yes! Chat, look at that! Look at that! Beautiful log messages with colors. Isn't that a good ending of a stream? Let's make it bigger. Do you see that, chat? Isn't that beautiful? So we have now all the log messages created by Rust tracing. Nice. Yeah. And if not, all the colors. Yeah, Kauchik, nice. Yeah. I'm happy. I'm happy, guys. This looks really good. And now we can use this to create JSON log files. And now we just have to convert all the places that write the logs to the new format. And when Piotr's tracing PR gets merged, we just have to do the same what he did with the tracing library. Cool. So I want to commit this. And call it a day. So the div. So we added a bunch of stuff here. Of course, it's very rough still, and we have to clean it up. But it works, and that's the important thing. And we can make it nicer now. Yeah, great. Let's commit all of that. Switch to or replace speed log. Oh, and I can then delete the speed log submodule with Rust's tracing crate. And let's push that. And yeah, I'm going to continue cleaning that up and maybe provide some good defaults so that when you start the node that you immediately get log messages and you don't have to provide the environment variable. Yeah. AAK says, oh yeah, good job, Gustav, thanks. And Daphnal says, by the way, are you using fish? Yeah, I switched to fish, and I like it so far because it's just, it offers a lot more features and has very sane defaults. I'm happy with fish, yeah. Yeah, that's change I made, I think, 2 weeks ago or something, and you immediately noticed that. That's that's funny. Okay, it was a pleasure, guys, and I'm really excited that this worked out. Next stream will be... I'm not sure if I can stream next Tuesday, but I'm going to announce the next stream on Twitter as usual. So it's either next Tuesday or the Tuesday in 2 weeks. But from now on, the streams, they will be regular again. All right, guys, so thanks for watching. Join the Discord if you haven't already, and click subscribe if you haven't already. Have a nice week, and see you next time. Bye, NanoFam.